Alrighty, what we have here is a sample problem. It is about two particles are traveling in space. Particle 1 has a mass of 2.01 kilograms. It has a velocity of 2.56 I hat plus 1.85 j hat minus 3.07 k hat meters per second. Particle 2 has a mass of 3.35 kilograms and has a velocity of 1.37 I hat minus 0.93 j hat plus 6.12 k hat meters per second. Determine the following for these two particles: velocity of the center of mass. So what we're doing is we're going to add momentum. Momentum is mass times velocity. So the sum of the momenta is going to equal m1 v1 vector plus m2 v2 vector. And we'll get the total momenta vector. So this becomes, how would be the right way to do this? It'd be m1 v1 x hat plus m2 v2 x hat plus m1 v1 y hat plus m2 v2 y hat plus m1 v1 z hat. Yes, I'm using x, y, and z. Deal with it. It's ijk, same thing. Plus m2 v2 z hat. I'm committed now. So this becomes 2.01 times 2.56 x hat plus 3.35 times 1.37 x hat plus 2.01 1.85 y hat plus 3.35 times negative 0.93 y hat plus a lot of moving parts on this guy. Nope. 2.56, 1.85, negative 3.07, and 3.35 times 6.12 z hat. So 256, 185, negative 3.07, 1.37, negative 0.93, and 6.12. And that gives me a total momentum of, let's calculate this thing, 9.74 x hat plus 0.603 y hat. And they want the velocity of the center of mass. And then the z .33. I could probably get away with just the 0.6. And this is in kilograms, meters per second. That's the momenta. What you do is, to get the velocity vector back, you take the momenta vector and you divide by the mass. So it'll be 9.74 divided by, and this mass is the combined mass, M1 plus M2. So 2.01, 3.35 x hat plus 0.6, 2.01 plus 3.35 y hat plus 14.33, 2.01, 3.35 z hat. And if you do that calculation, and I'm just going to get the mass, total mass together right now. Total mass is 5.36. So your final velocity vector is equal to 1.82 x hat, or I hat, whatever you want, whatever you need, it's the same thing. Should give you that. And that is the velocity vector in meters per second. So all you had to do was, you've got the mass with each velocity, you add the momenta vectors, add your vectors. Vector addition is critical. Vectors are bedrock to physics. So the last bit, the total momenta of the system, they're just looking for the magnitude. Or wait, are they or are they not? They're looking for a vector. If they're looking for a vector, then this is the answer of what they're looking for. All right. Hope it helps. This is mainly for a student of mine who had a question, and hopefully it worked out. If it doesn't, then I'll probably take the video down. If you first make a mistake, destroy all evidence that you even tried. Have a good day, and as always, go to lab.